So let's look at this question. A ram of 150 kg is released from breast 0.5 meter over a plate of 5 kg, which is supported by a spring of stiffness K is equal to 15 kN per meter. The spring is initially stretched by 98.1 mm. We have to determine the compression of the spring. So we're given a ram and a plate. The ram is above the plate, as you can see from that given figure. The plate is connected by a spring, and it is at a distance 0.5 meter from the bottom level, while the distance between the ram and plate is also 0.5 meter. We have to find the compression formed due to the after collision of ram with the plate. We know that 150 kilogram mass is colliding with the 5 kilogram plate, so it will definitely cause a compression due to the spring attached to the bottom of the plate. So let's look at how to solve this problem. So first, I have written the given condition mass of the ram. I am representing it as mr, which is 150 kilogram. Then mass of the plate, which is represented as mp, 5 kilogram. Then stiffness, 15 kilonewton per meter is given in kilonewton per meter, but I have to convert it to newton. Okay, converting into basic standard unit, so it will become 50,000 newton per meter. Then initial stretch of the spring, they already told, right? The spring is initially stretched at 98.1 mm, and I have to convert that to in meter, so it will become 0.0981 meter. Okay, then I am assuming let it be called h, which is the height above the plate, be 0.5 meter. That means the distance between ram and plate b, I am calling it as h, and it is 0.5 meter. So the basic principle to solve this problem is principle of conservation of energy, right? Energy cannot be destroyed, it is always converted from one form to another. So the same way I am doing this problem. So I have to find the what all energy at the initial condition, then I am finding what all energy after colliding the final condition, simply equating and finding the respective term. That's the basic idea to solve this problem. So let's look at the initial condition. What are the energy in this given condition? What are the energy present at this given arrangement? So as you can see, ram is at a height of 1 meter from the ground and 0.5 meter from the plate. Okay, so basically it's at a height h. So we know the basic idea of potential energy. The one which is having at a height h, it would have potential energy. Suppose it is at a height h, it would have a potential energy of mgh. So ram having potential energy h above the plate. So why am I considering 0.5 meter, not 1 meter? Because the potential energy stored just because of the height of 0.5 meter is which cause the colliding. I mean, conversion of that only that much potential energy is converted into when it collide with the plate. So I cannot take 1 meter, only I need to take 0.5 meter, because that potential energy at that 0.5 meter height is converted into the spring energy after colliding with the plate. So only you have to consider 0.5 meter, not 1 meter from the ground, just the 0.5 meter from the plate. So the ram having potential energy h, I know I already called h as distance between the ram and plate. So the basic formula usually mgs given mass 150 kilogram, g 9.81, and h to be 0.5 meter. So finally I get the initial potential energy of the ram to be 735.75 joule. Okay, then apart from the ram, there is a plate which is connected to a spring. As you can, we already know that spring will be having a spring energy, right? That's the basic idea of a spring. A lot spring would have, it would store a spring energy, and initially they already told it is stretched by 92.1 mm, so it is having slight deflection, so it would have a spring energy. So the basic formula of spring energy is simply half kx square, x to be that displacement or stretching. So I am assuming, since it is the initial condition, I am calling it as x naught. So u, or potential energy of the spring I'm calling it as initial, since it's the initial condition, I'm calling it as x naught. So it is half k x naught square. So half into k is 15,000 and x naught is 0.0981 meter. So I got the initial spring energy as 72.1 joule. So the total initial energy, the energy due to RAM and due to plate, I will just simply add it. It got us 807.9 joule. Okay, so I will explain this the initial condition. So RAM is having a potential energy due to the height, and spring is having a spring energy. So these are two energy before colliding of the RAM and plate. So simply add the both energy, you get the total initial energy. So I got the value as 807.9 joule. So the now let's look at the final condition. I mean, after hitting with the plate, the RAM hitting plate, let's look at the final condition. So the final condition after hitting the plate, we know the spring would be after that plate would move a slight distance due to the force exerted by the ram on the plate, right? So, so assuming that after the collision, it will move through a distance x. Okay, it would do some further distance downward. I am assuming it to be x. So the ram alone won't have any potential energy. Okay, after collision, the ram we are not considering as a single unit. We'll be considering as a system. Okay, so the potential energy of the ram will become zero. At the potential energy, it was at a potential energy, but after heating, it would suddenly become zero after to collision. Okay, then the spring, of course, it should have the spring energy because it is moving through a slight deflection x after collision. So it should definitely store some spring energy. So I am writing it as half k x square. Okay, that final deflection to be x, so obviously the spring energy would be half k x square. So after collision, the ram and plate together form a system. Yes, it was actually before collision it was separate unit, but after collision they become a single unit to be a system. So after collision, guess what? It would have a potential energy. That system will be considered as a total system. We cannot consider along. RAM cannot. We can't consider like that because it's not a single unit. After collision, it would become a combined unit. So the potential energy of the system, the same formula, simply mgh, but mass is not for the plate. It's the sum of both RAM and plate because you have to consider the mass of the system, right? So after collision, it would be the sum of the mass of both RAM and plate. So mr plus mp into g into h. So how do you define h? Right, as you can see, the plate was initially at 0.5 meter from the surface, but after collision, we already assumed it is moved through a distance x, right? So initially it was 0.5, and it's moved through a distance x after after collision. So the final distance from the ground will be what? 0.5 minus x, right? That will be the remaining distance to the that surface level of that system. Okay, so that h would be 0.5 minus x because this is the potential energy of the system after collision. So after collision, it will move through a slightly distance x, and the distance x will be 0.5 minus x. So I already know the plate was at a 0.5 meter from the ground. So after collision, we assume move through a distance x, and so the final distance from the ground will be 0.5 minus x. Okay, so the potential energy due to that distance of that system, we know it is not a single unit now, it's both RAM and plate. So that is mr plus mp into g into 0.5 minus x. So guess what, now to find the total final energy, you simply have to add the both energy of the spring and system. So I got the final energy too. So as I already explained the first part, you have to apply the basic principle of conservation of energy, that initial energy and final energy are same, right? The total initial energy and total final energy are same. Energy is conserved. It is always converted from one form to another. It cannot be destroyed. Okay, so initial energy, I already told the total initial energy. Now I got the total final energy. Simply equating, we have to find the value of x, right? That's the final deflection after collision, and that is what they asked to find, right? The compression in the spring. You have to find that value. So simply that x value, you get a quadratic equation. Okay, so after solving that, I got the value. We'll get the value as x is equal to 0.3 meter, 0.23 meter. So that's the final deflection or the compression in the spring after the collision of ram and plate. Okay, this is the way to solve this problem. We have to simply apply the principle of conservation energy and take all the total initial energy. We have to find separately total initial energy, what all energy present before collision, and you have to find the total energy after collision, simply equating and find the required term. Okay, this is a basic structure, basic method to solve this type of problem. Simply apply the principle of conservation energy. Because this is a collision problem, of course there are different forms of energy: spring energy, weight, potential energy. So simply apply that principle and solve this problem. Okay, so this is how you find it.